Assalamu alaikum. Welcome to the class of Requirements Engineering. The course code is CSE305. My name is Dr. Naveed Ahmed, and apart from welcoming to this course, I would be talking about what we will be covering in the course. I will start with a very brief introduction about myself. As I've already told, my name is Dr. Naveed Ahmed, and I've done my PhD from University of Cambridge. I finished in 2010. I have a combined experience of more than 10 years, which involves industrial as well as academia experience. Since coming back from Cambridge, I have been associated with ComSets University, Islamabad campus. In terms of my industrial experience, before going for my PhD, I was working in industry. I've worked with different software houses. I worked as a consultant, and I've filled different roles as a team member, as project manager, and I'm also involved with different industries right now, consulting different projects. In terms of research groups, I'm chair of two different research groups at CIIT Islamabad campus. One is Software Engineering Research Labs, and as the name sounds, this is a big group where we basically have lots of different students, MS students and PhD students working under us, and lots of colleagues of ours. And they basically, we cover broad areas of software engineering. For example, requirements engineering is one of them, software project management, change management, quality testing, and all those different areas which are included with software engineering. And the second research group which I am part of is ComSet's Mobile Application Development Lab, and we are not sort of more into research in this area, but we are interested in how CIIT can play its role towards building enterprise applications. And we have some experience with working with different institutes in the past, and we are still working towards it, but we are also interested in doing some research in this area. In terms of my publications, as I already mentioned, my main research areas under Software Engineering Research Group is process engineering, and that was my main topic of my PhD was process engineering and change management. And as you can see, most of my publications are from the area of change management. And so we have, my area was, in my PhD, I proposed a framework to capture information, to capture the design information, and so that which would facilitate in analyzing the impact of changes in the design. We are also working on different other areas, but my main interest is engineering change management. And these are few more of my publications. As you guys can see, that they mostly cover the domain of engineering change or change management or dealing with change requests. Very briefly telling you about it, I know by now you guys have gone through the courses on software engineering, so you guys are pretty much familiar with what is a change. And when we will go through this course of requirement engineering, then you guys will appreciate that changes have a huge impact on any software. And you guys would realize that managing changes is really important. If we manage changes well, then we can ensure that we are going to complete the project on time and within the budget, and we will also satisfy the customer as long as the scope is concerned. So my research was on basically that how we are going to manage changes in a better fashion. And apart from proposing a framework which I already told you about, I ran some simulations that what are the best strategies to deal with the changes. And one of the favorite things which I did, or one of my favorite papers which I worked on was a simulation where I suggested that if we batch changes together, then we can reduce the lead time. So we can reduce the delays in the project if we batch changes and process those changes together. We are going to talk about it more in our later lectures when we talk about requirement changes and how they impact a software, or how they impact the software lead time. Now let's move towards our course, this course of requirements engineering. Very briefly, I'm going to tell you about that what are the objectives of this course and what are the things that we should try to achieve in this course. So we will talk about fundamentals of software requirements engineering. We will talk about role of requirement engineering in software lifecycle. You guys have gone through different software development life cycles. For example, the waterfall model, the incremental model, the spiral model, and some agile methodologies as well. Now, if you look at all those different process models, then one thing that is common in all those life cycle models is that every one of them starts with requirements. Every one of them starts with the analysis portion. So it actually shows the importance of this area of requirements engineering. So when people came up with the idea of software engineering, they knew that in order to engineer a software in a better fashion, or in order to engineer a software, they need to gather requirements. But later on they realized that, gathering requirements, there should be a proper method of gathering requirements. That's why this course of requirements engineering. We are going to talk about more of this in our later lectures. Then we'll talk about the requirement engineering process, that when it was proposed, so what is the process of requirements engineering? What are the activities which are involved in the requirement engineering? So we are going to talk about it. So few of the activities which are involved in a requirement engineering process are elicitation, elaboration, specification, negotiation, and all those things. We are going to talk about that, and we are going to, our course is basically structured around the requirement engineering process. Then in detail we will talk about requirement elicitation process and different techniques for requirement elicitation. So when I say requirement elicitation, what do I mean by elicitation? It means that when somebody goes and try to get requirements from a client. So I'm trying to elicit, I'm trying to ask, I'm trying to get out of the client that what do you want in your software. So that is what elicitation is about, and there are different techniques. For example, the simplest which would come in your mind is that you go and talk to somebody. So you're conducting an interview. So that is the simplest technique. Another technique is that you send a questionnaire to somebody, and you collect those questionnaires, and on the basis of the answers you compile what you have gathered from those questionnaires, and you prepare a list of requirements. So that is very briefly what elicitation is about. Then we are going to talk about requirement analysis and negotiation. I hope that in your courses in software engineering, because they are prerequisite to this course of requirements engineering, you have gone through different analysis techniques. When we say analysis, when we are saying basically we are trying to actually analyze what we have gathered from the clients. So for example, a requirement is just written text. So it can be a small paragraph, it can be one line, it can be two lines describing some feature of the product that client wants. Now when we say analyze, then we have to actually understand that what does the client mean by this particular line. So at times the problem with expressing requirements in text is that we express a requirement in any natural language, be it English, be it Urdu, or any other language for that matter. But these languages, they have ambiguity in them. And when we say they have ambiguity in them, then we are actually saying that client might have wanted something else, and we might have picked that he wanted something different. So in order to actually be on the same pitch as the client is, we basically want to analyze requirements in detail. And when we have done our analysis on the requirements, we go and then we talk to the client, and that's where negotiation comes in. We go and talk to the client and tell him that okay, we thought that this is what you want, so is this really what you want? And then we try to finalize the requirements. Then we'll talk about different types of requirements. Broadly, requirements are categorized into two categories: functional requirements and non-functional requirements. And as their name suggests, the functional requirements, they basically are the requirements which are concerned with the functionality of the product that you're producing, whereas non-functional requirements are those requirements which are not directly related to the functionality of the product, but they involve features such as usability, that how easy is the product to use, or how easily the new users can start using the product, or how reliable is the product. So we are going to talk about different types of requirements and how can we express requirements, and how for different kind of softwares, what is the difference of, or what is the importance of non-functional requirements for different categories of softwares. Then we'll talk about some requirement engineering methods. Then we'll go and discuss how we validate requirements. Validating requirements is really important, and it is part of the software validation, that we basically, when we say we want to validate a system, then we actually validate it against the requirements that we have gathered, because we have to tell the client, because a requirement is the only source which is used to deliver. When you are delivering a product to the client, then you basically go and show the list of the requirements that you gathered at the beginning of the software development lifecycle, and you go and tell the client, okay, these are the 10 requirements that you wanted in your product, and we have delivered 1, 2, 3, 4 up to 10, and we have done it all. And once you show all those features in the product, only then you can satisfy the client. So requirements validation is very important. Then we'll discuss about requirements management, and that's where the change management, my research area, comes in. That when we talk about managing requirements, then it's managing is a very broad term. It's not only involved with gathering requirements, it's not only involved with analyzing requirements, but it means that throughout the life cycle of the product, we are trying to manage some set of requirements. And by managing, we mean that whenever a change comes in a requirement, then we have to understand that change, we have to analyze that change, and if we have to incorporate that change in the product, then we have to show it in the requirements document, we have to show it in the design of the software, and we have to update our project management plan as well accordingly. So requirement management is a very critical process, and if not done properly, it can be very disastrous. And for example, for a bigger software, if requirements are not managed properly, then it's highly probable that you are going to fail in your endeavor in completing the software on time, within the cost, and within the scope, and complete the scope as well. Then briefly, this is the agile era. Lots of smaller software houses are, there are lots of new startups in the industry when you look around, especially in a country like Pakistan, where we do lots of outsourced work. There are lots of small companies where the team sizes are 10, 15, 20 people, and the most suitable process model or the life cycle model that they chose when they are developing software is agile. So we'll specifically talk about that in agile methodologies, how are requirements collected, how they are managed, how they are analyzed, and how they are validated. So we're going to talk about that as well. Okay, so those were the objectives. Now let's look at what should be the learning outcomes of this course. So one of the key learning outcome is that every one of us understands the key elements and models of requirement engineering process. Another course learning outcome is understand and analyze common methods for requirement elicitation and select appropriate methods to produce a set of requirements for a medium-sized software system. So we are not aiming too high that we are going to learn techniques and we are going to be very proficient when we go out and elicit requirements, and it doesn't matter how big the software is, but we will be good in eliciting requirements, because this is the first course that you are taking on requirements engineering. So we will try to familiarize you with different elicitation techniques, and it is very important to pick a suitable technique for us for a particular criteria. Because when you go and you talk to the client, then what happens is that depending on the client expertise, you have to choose a different method. If your client is well informed, then sending him a questionnaire is maybe it's sufficient. Whereas if he is not an informed person and he is not even literate in computer sciences, and he is not a good computer user in general, then the best method would be maybe to show him a prototype and then try to gather requirements. So you cannot get away with sending a questionnaire or conducting an interview and start asking very particular requirement engineering questions. So you have to choose a technique that what is the best method to get requirements from a certain client. So we'll talk about different examples when we'll go and discuss the different elicitation methods. Then we will understand the key components of a use case and produce possible use case to analyze system behavior and requirements. I hope all of you guys are familiar with the use cases and why they are used and what are the different elements in a use case, but we are going to talk about them in terms of requirements engineering in this course again. We will identify functional and non-functional requirements for a certain requirement specification document, and I hope you guys will have the ability to differentiate that that's a functional and that's a non-functional requirement. We'll also talk about other types of requirements, such as, for example, domain requirements. We will be covering all different types of requirements in detail. Then another learning outcome should be or use a standard method to develop software requirement specification document for a medium-sized software system. And finally, the final learning outcome is that conduct a review of a set of software requirements to determine the quality of requirements with respect to the characteristics of good requirements. So these are the learning outcomes that I have set out for you guys, and I have set out for us to basically get from this course on requirements engineering. So let's briefly look at the course outline, and the course outline is organized in terms of units and topics, and I've mentioned that how many teaching hours we're going to spend on each topic. So the unit 1 is introductory, where we are going to talk about, as this lecture is Introduction to Requirements Engineering, and we will be talking about in remaining portion of the lecture about what are requirements and what is requirement engineering, what is the requirement engineering process, how a requirement engineering document looks like, how it is produced, and what is system engineering. So we are going to talk about these things. And with each topic, you can see that I have mentioned that which book you have to consult and which chapter you have to consult. I will be showing you the detailed full title and with the author names of the book in the coming slides. So we are going to spend almost 3 lectures on in the introductory portion. Then we are going to talk about requirement engineering process activities, and I told you there are mainly 7 activities, 7 or 8 activities: inception, elicitation, elaboration, negotiation, so on and so forth. So we're going to talk about them, and this portion of the lecture would be covered from Pressman, the book that you might have already used in your software engineering course. Then we are going to talk about requirement elicitation, and what is the elicitation process, what are the barriers in elicitation, and what are the different techniques for requirement elicitation. And and then the next area is we're going to talk about how do we write functional requirements, because this is very important for you guys to learn. And one interesting thing that we are going to do throughout this course is that it's good to learn the theoretical side of things, but I want you guys to be good in applying those things. So for example, if somebody comes up and say, okay, this is the product. For example, if somebody says, okay, can you mention some functional requirements of a portal, like for example, Facebook, and so you should be able to quickly identify, okay, what are the functionalities in Facebook. I mean, it's a huge product, and it will take you, I think, number of days to actually list all the functionalities which are there in Facebook. But you guys should be familiar with what are the functionalities in a product, and you guys should be able to identify, okay, how do we write the functional requirements of a product. So we're going to talk about them as well. Then we'll talk about non-functional requirements, because in my experience, it's always easier to identify functional requirements. And when I say it's easier, I mean that it is easier for the client to figure out, okay, what are the functionalities he or she wants in their software, and it's easier for a requirement analyst to identify, okay, these are the functionalities that you want. But when it comes to non-functional requirements, I'm not talking about the students. What I've seen in my experience and teaching experience, that students find it hard to identify non-functional requirements, and they find it really hard to specify non-functional requirements. Why is that, first of all? Because most of these requirements, they are written as qualitative statements. For example, when we say that product should be, for example, let's say reliability is a non-functional requirement, and at times what statement you found written in different requirement specification documents is that system should be reliable. Okay, now that's a very ambiguous statement. What do we mean by should be reliable? Should it work 8 hours every day? Should it work 12 hours every day? Or should it be operational 24 hours a day? So we have to be very specific when we are mentioning non-functional requirements. So we are going to talk about them, that how do we classify non-functional requirements, how do we derive non-functional requirements, and how do we mention these requirements for critical system. As I said in the beginning of this lecture, that the importance or the way we write non-functional requirements, it would vary from system to system. For example, if I am making a static website, if I'm making my personal page, then non-functional requirements are not really that important, apart from maybe the the usability, but reliability is not such an important concern. Whereas if I am working on a very safety critical system, then non-functional requirements and reliability and usability and all these things, they become very critical, and I have to be very vigilant when I am writing those non-functional requirements. So we are going to talk about that. How do we mention non-functional requirements for safety critical systems? Then we are going to talk about what is requirements management, and we're going to discuss what are stable and volatile requirements. So now that's a word which is used very frequently in literature, volatile requirements, or it is called requirements volatility. It is mentioned in different papers. What do we mean by volatility? That requirements are subject to change. Okay. Now, one of my favorite questions which I always ask in interviews from different students who are interested in working with me or who are joining the software engineering department is that why do you think that softwares fail, and what is that? Why the frequency of software failures is huge in comparison to the bridges falling down? So and I failed to get the correct answer from, you know, I think I've never got a very or the answer that I'm looking for, that what is the reason for requirements failure. Now what I believe is that when we talk about construction of bridges, now that is basically civil engineering, and when we are designing a bridge, then the design of the bridge is finalized before its construction. And for example, if that's a pedestrian bridge that I am going to design and I am going to build, then I will never say halfway through its construction that, okay, no, I'm also planning that some cars would also go through that pedestrian bridge. Because it's never going to happen. The bridge will never support it, and it's sure to collapse. And nobody is going to accept that change when they are in the construction process. Whereas what happens with the software is that normally client and generally the perception is that you can always change requirements of a software, and you can do whatever you want with the software. Now that's where this volatility comes in, that requirements of a product are volatile. So that's why we say that in software engineering or in software construction, that's a huge problem, volatile requirements. So we are going to talk about that. What is volatility, and what are volatile requirements, and what is the impact of those volatile requirements, how we can actually assess the impact of volatile requirements. And that's a very interesting research area. Lots of researchers are working on it, and they have proposed different methods, and they have deployed different techniques to understand the impact of volatile requirements. Then we'll talk about different methods of requirement engineering. We'll talk about data flow modeling, semantic data models, object-oriented approaches, and we will briefly talk about formal methods as well. Now, for example, you know, formal methods is a huge topic on its own, and I'm sure you guys will have another course on formal methods as well. But we will have a very brief introduction of what are formal methods, and we'll try to spend a lecture on it. Then we'll talk about requirements validation, and we'll see that what are the different activities involved in requirement validation, what are requirement reviews, what is prototyping, model validation, and what are requirement testing, and all those things. Then the final unit, or the final topic that we're going to discuss in this course, is requirement engineering for agile methods. As I already mentioned in the beginning of the lecture, that agile methods are in fashion these days. And lots of new or smaller software houses, either knowingly or unknowingly, they are following agile methodologies. And they have figured out that, you know, that's the solution to all their problems, that because they realize that requirements are going to change, and they do not want to invest too much time in specifying or writing requirements and producing detailed design documents. So they say, okay, we are going to use one of the agile methodologies. So and you guys have to work within this industry. So we are going to discuss different that how requirements are elicited, how requirements are documented, and how requirements are managed within those agile methodologies. So let's quickly discuss which textbooks we are going to follow in this course. The first one is by Cotonia and Somerville, Requirements Engineering Process and Techniques, and the other one is Software Requirements Styles and Techniques, and it is by Soren Lozin. These are the main books that we are going to follow in this course, but there is no limit to the reading that you can do. And when we talk about different requirement engineering techniques, for example, when we talk about elicitation methods and techniques, then what I will be doing, that I will with each lecture I would propose that, you know, this is what you should read. And so I would try it. If I propose that you should go through a research article, then I will be supplying you with that. But these are the other reference books which are really useful. For example, by Ian Cabre, An Introduction to Requirements Engineering. Now that's you can also have that if you have access to this book. Then a book by Carl E. Wiegers, Software Requirements. Then there's a book by Dick, Hull and Jackson, which is Requirements Engineering. And then the book that you must have had in software engineering is by Roger S. Pressman, which is Software Engineering: A Practitioner's Approach. That's always a helpful book to have, a very handy book on software engineering. So these are the reference books that you guys should, or if you have access to these books, then they are also very informative for this course. Now let's come towards, that was my introduction and journal brief introduction about the course. Now let's start our lecture today, and let's discuss that what is requirements engineering. Now, as you guys, as I stated in the beginning of the lecture, is that that when we say software engineering, then we define software engineering as something that why people thought we need to engineer software, okay? And I say it always in my lectures that engineering is a older discipline than software, and software is a very new discipline. And so people realize that engineering products, they don't fail as often. So we have so many examples of failed softwares and the software is not being made on time. So this field came that we need to engineer softwares. We need to figure out a engineered fashion or an organized fashion in which we can identify, okay, if we do these things, then we are going to finish our software on time. So that's why this field of software engineering came in. And one of the few things that we do always when we are learning software engineering is that we try to learn and we try to teach different methodologies or different software development life cycles. Now, under software engineering and in those when we talk about those life cycle models, then you guys have gone through waterfall model, incremental model, prototyping model, and spiral model. Those are the traditional life cycle models. Then one thing that is common in all those different methodologies is the analysis portion. So every academic believe, or every researcher believe that, or they have seen in the practices that without understanding what is required by the client, you cannot complete a software, or you cannot actually satisfy a client. So we need to carefully gather requirements, we need to carefully analyze requirements, we need to carefully validate requirements. So in software engineering, we learned what are the different activities that we should do in order to build a software in a better fashion. But analysis is such an important portion of software development, or requirements is such an important portion of software development, that people realize that just mentioning that we need to gather requirements is not enough. We need to define and we need to identify that what is this requirement engineering, or how we can actually propose a organized method of gathering requirements, organized method of dealing with requirements. So that's why this field of requirement engineering emerged from. Okay, so before getting to formal introduction of requirement engineering, let's talk about the system requirements. What are requirements? So in general, when we say, when we try to define system requirements, then these are the things which tell what the system would do and what are the constraints under which the system would operate. Okay, so let's say we are trying to write requirements, or we are trying to identify the system requirements for a library, okay, or a library management system. Then what do we write? So for example, let's say these are the requirements, and we try to identify that how they are telling what the system would do and how they are actually mentioning that what are the constraints on the system. So for example, we are saying that system shall maintain record of all the library materials, which include books, newspaper, magazines, and all those things which are there in a library. Secondly, we are saying the system shall allow users to search for an item by title, author, or by ISBN. The system's user interface shall be implemented using a World Wide Web browser. The system shall support at least 20 transactions per second. The system facilities which are available to public users shall be demonstrable in 10 minutes or less. So we have written some sort of requirements here, and if we are not too picky on these requirements, then we can say, okay, that there are some requirements which are telling us that what the system would do. For example, the first one is saying that system would have all the records of everything that is there in the library. The system allows the user to search for all the library materials through different ways. It allows to search by author name, it allows to search by the title, and it allows to search by the ISBN number. And then we are also mentioning some constraints on the implementation of this library management system. For example, we are saying that it should be a web-based system. We are not talking about a desktop application. We are saying it should be a web-based system, so people would have access to it from anywhere they are willing to use the system. Then we are also mentioning some other constraints. For example, we are saying that every transaction should take so it should not take more than 20, so it should be able, we were saying that the system should be able to process 20 transactions in a second. So that's another constraint that we are putting on the system. And then another constraint that we are putting on the system is that all the functionalities should be demonstrable in a certain time frame. So this is a sample of requirements, and as I said, that they are not good requirements, but they are just a sample to tell you that they are in some way telling that what the system should have. Okay, so let's see what are the different types of requirements out there. And as I said in the beginning of the lecture, in one of the slides, that broadly there are two categories of requirements: functional requirements and non-functional requirements. But when we are talking about general requirement engineering process, then when we start working on a project, and as a requirement analyst, when we say that we have to start the requirement engineering process, then we are not all that blank. For example, we have some sort of clue that what is to be built in a product, or what is generally, for example, if we are going to meet a client, then we are prepared in some fashion. So we already have with us some sort of general requirements, which are very broad and which we don't actually mention, or which we don't actually specify in our requirement specification document as it is, because they're too broad and too general, because we need specific details for implementing a product. So but they are very useful. And the next come the functional requirements, which are basically derived from those very broad requirements, and we try to identify that what are the key functionalities in the system. For example, from the last slide where we discussed the library management system, then we mentioned different functionalities. For example, one of the functionalities was that the system should maintain the record of all the things which are there in the library. For example, the books, CDs, magazines, newspapers, and all those things. Then another functionality which was discussed was that system should have the search functionality. So, and the user should be able to search by title, by author name, and by other details as well. And there can be other functionalities which we can think of. For example, in terms of the library management system, you can say that you should be able to run different sort of reports, that how many users are active, and how many books are overdue, and what is the fine collected for a certain time period, and these kind of things. So there can be different functionalities that you can think about. And as I said, that thinking about the functional requirements is relatively easier than the non-functional requirements. And then there can be some implementation constraints that we can put on any software project, and these are called implementation requirements. For example, from the last slide again, when we said that library management system, it should be a web-based system. So we put a implementation constraint on the system. We can also be more specific. For example, we can say that the technology used should be open source. For example, the site should be built in PHP. So we are putting another constraint on it. So this is another example of implementation requirement. And then comes the category of non-functional requirements. And within non-functional requirements, we have different categories. We have performance requirements, we have usability requirements, we have maintenance requirements, we have lots of those things. And when we say performance requirements, then we actually, what do we mean by performance requirements? So performance requirements specify a minimum acceptable performance for the system. For example, we said that that system should be able to process 20 transactions per second. Now that is the minimum level of the performance that we expect from our system. So we have, if there is a minimum level defined for your system, then you need to clearly state that. Okay, so a statement like that the performance of the system should be good or it should be acceptable, they're not right, because they're too vague. We need to clearly mention, for example, in terms of a system like library management system, that how long should it take, or how many transactions should be processed, or how many users it should support at one time. And then comes the usability requirements. For the usability requirements, they specify the maximum acceptable time to demonstrate the use of the system. Okay, so we want to mention that there are different types of users of any system, And so we have to say that how long will it take for all those users to be able to use the system? How long will it take for us to show this functionality of the system to the users, and how long will it take for them to get familiar with the system? So we also need to be very specific when we are mentioning that those usability requirements. Now, one slide is not enough to mention what are the problems with requirements. But these are some of the things that came in my mind, and as we discussed, we'll talk about some more things or some more problems with the requirements. First is that the requirements, they don't reflect the real needs of the customer for the system. Now this happens a lot. As I said, that requirements are normally expressed in natural language, and they're written in natural language. And for example, when a requirement analyst is talking to a client, then client is expressing something and the analyst is thinking in another fashion, because analyst has a particular experience of a particular domain, and whereas the client is not, they are not a perfect match. So what would happen is that the understanding of the analyst would be different from the client. So what analyst wrote doesn't match what the client wanted. So that's a very serious problem with requirements, that an analyst thought differently to what the client wanted. Another problem, and this results in lots of inconsistencies in the requirements. And inconsistencies not only originate from this gap between the client and a requirement analyst, or a guy who is there to gather those requirements. Inconsistency also comes from that because when we go and gather requirements, we normally talk to multiple stakeholders. So for example, when we go to a client side, then we will talk to multiple people. For example, if you're making a university management system, then you're going to talk maybe to some students, you're going to talk to maybe the exams department, you're going to talk to faculty, you're going to talk to HR, and you're going to talk to different people. And you're going to talk to, I don't know, administration as well. So when we are talking to different people, then everybody would have their perspective on something. For example, when we talk about course registration, then students would have their perspective that how the course registration process should be, or how the course registration functionality should be implemented in the software. Whereas when we talk to administration about it, then they would have different view on it. And that's where the inconsistencies comes from, that one user of the system want functionality in one way and the other user want it in a totally different way. So which one is right? That's job of requirement analyst to figure out, and that's job of a requirement analyst to figure out, to identify first of all what are the inconsistencies in the requirements, and then to deal with them, and then to fix them, and then to so that we have a consistent set of requirements in our hands. Now the next is incomplete requirements. As I've given you different examples, that for example mentioning that performance of the system should be good, or system should be usable or easily usable, these are incomplete requirements, because we are not clearly mentioning that what do we mean by good performance, or what do we mean by usable system. So we need to be very specific. We need to mention requirements in detail. Okay, or let's say we are mentioning functionality of the system, that system should be able to generate multiple reports. Now what kind of reports should we want from the system? For example, in terms of university management system, and we are talking about course registration, so do we want a course registration report, that how many students have registered a particular course in a semester, or so what kind of reports we are talking about? So in general, we need to be very specific when we are writing requirements. So another problem is inconsistent or incomplete requirements. Another problem with the requirements is that it is very expensive to make changes to requirements after they have been agreed. Okay, and when we finalize the requirements, okay, and we are in the design phase or we are in the implementation phase, then the cost of change in the requirements would increase. Okay, if we identify that there is a problem with the requirement, or if the client identifies at the beginning of the software, when we are in the requirement engineering phase, that or we are in the analysis phase, that there is a problem with the requirement, then it is cheaper to fix that, because we haven't started the design yet, or we are not in the implementation phase yet, so it is easier to fix that. But let's say we are past that, we are in the design phase now, then the cost would increase, and so forth. For example, if we are in the implementation phase, then a change in that same requirement would be more costly because it would generate more rework, because there are lots of other things that would change. It might change the design, it might change my original implementation, or let's say that the system has already been deployed and the client says, okay, no, or when you go and to show the final system to the client, he says, no, I didn't want that, and he says, okay, now this is the new requirement that I want, or this is the change requirement, that it will be very costly. So changes are very expensive in the requirements. So that's why the requirement engineering process is very important. That's why the requirement management phase, requirement validation phase, the negotiation phase, these are very important. Because when we are validating requirements, we are validating it with the client. We are discussing it with the client that, okay, this is our interpretation of what you want. So is it in line with your interpretation? And then we finalize requirements. So careful attention you should be very careful when we are going through this process of validating the requirements. Then finally, there are misunderstandings between customers, those developing the system requirements, and software engineering developing or maintaining the system. Now, we talk about the first kind of misunderstanding, which is between the customer or the client and the requirement analyst. Then there are also misunderstandings between the requirement analyst and the developers of the system. Okay. Now they also need to be in line. There need to be some communication between the developers or the software engineers and the requirement analyst, because it is very important that all the people working on a software, they have the same understanding, or they are working at the same level. Because if they are not, then we will produce something else. Because even though the client and the requirement analyst, they understood what client wanted, and requirement analyst also understood what client wanted, but if the developer or the software engineer, he did not understand that, then again, the functionality won't be delivered, or there will be lots of rework at it, because when software engineer would say, okay, I've done my work, and it will go to testing, and then when the team would take it back to the client, he would say, no, I didn't want that. So basically, there need to be a constant communication between all the stakeholders involved, that to ensure that everybody is at the same level. Okay, so these are different problems with requirements, and I'm going to give you multiple statistics in the next lecture about what is the percentage of projects which are failed due to problems in requirements. But let me assure you, it's huge. The number is significant. Lots of softwares, they fail because of problems in requirements, either inconsistent requirements or incomplete requirements, or misunderstanding between client and requirement analyst, or between the requirement analyst and the team. So very careful attention should be paid, and that's why I think this course is being introduced in this program of software engineering. That this is very critical, and from my industrial experience, I have learned that. Lots of good software houses, they pay very careful attention in gathering requirements, because requirements gathered in a careful fashion ensure that there are no problems with the client in terms of delivery of the product, and in terms of timely completion of the product. So it is imperative that requirements are gathered in a proper fashion. So let's discuss some of the frequently asked questions about requirements. Generally, what are requirements? Requirement is any statement of a system's service or a constraint on the system. So either it will be a service provided by the system, or it will be a constraint on the system. There are different examples of different statements. It can be a user level facility. For example, the word processor must include a spell checking and correction command. It can be a very general system property. For example, the system must ensure that personal information is not made available without proper authorization. It can be a very specific constraint on the system. For example, if there are sensors in the system, then what is the frequency of polling that sensor, or how frequently you should do it. So for example, we are saying that the sensor must be polled 10 times per second, and it can be some very specific domain related information. For example, if there is some computation involved, then how would that be done? So for example, the course overall mark, what is the formula that is used to calculate the overall mark for assessing a student? So over here saying that total mark is equal to exam marks plus 2 into project marks plus 2 by 3 into course mark. Now this is not the formula that we use, but I'm just saying that you can have this is also an example of a requirement. And it can be a constraint on the development of the system. For example, the system must be developed using C hash, or we can say it should be developed using Java or any other technology for that matter. Then what is a requirement engineering? The process involved in developing system requirements. Okay. So software engineering was process of developing software, and requirement engineering is the process involved in developing software requirements. And we have already talked about that there is a generic requirement engineering process within which there are different sub-processes. For example, inception, elicitation, elaboration, and all these sub-processes are also part of that big requirement engineering process. And how much does requirement engineering cost? Another frequently asked question is, what is requirements engineering? And as we have already discussed, it's the processes which are involved in developing system requirements. These are requirement engineering. And we said that there is a generic requirement engineering process, and within which there are lots of sub-processes. For example, inception, elicitation, elaboration, specification, and negotiation, and all those. These are all sub-processes of the big requirement engineering process. Then how much does the requirement engineering cost? Then it's about 15% of the system development cost, and this statistic, it comes from the chapter of the book which I mentioned at the beginning. And what is the requirement engineering process? The structured set of activities involved in developing system requirements. So in generally, what is a process? A process is a set of activities that you perform in order to achieve a certain goal. So when we talk about requirement engineering process, so we are saying that either it has some sub-processes, which would eventually would have some activities which we are doing to gather system requirements. So in general, this is how we define a process, and this is how we are going to define a requirement engineering process. So what happens when the requirements are wrong? This is a very problematic statement. What happens when the requirements are wrong? So it's disastrous, very simply. The system would be late, it would cost more, it will be unreliable, I don't know, client won't accept it, and if you won't be able to complete the project, it will cost you more, it will take more time. So there will be all sorts of problems if the requirements are wrong. So the next question is there an ideal requirement engineering process? No. In general, when we look at the field of process improvement, then a very interesting statement made by an academic was that all processes are wrong, but some are useful. Now that statement is very interesting, that when we say that all processes are wrong and some are useful, we actually mean that no process can be picked and used in a particular scenario. Okay, we always have to tailor our process according to our own context. And context is defined by, for example, who is the client and who is the company who is actually developing that product, or what is the experience of that company, how knowledgeable is the client. So that defines the context. And depending on your context, you pick a process, but that process cannot be used as it is for engineering or for gathering requirements. You need to tailor that process according to your context, and then that becomes ideal for you. So what is a requirement document? It is just a formal statement of system requirements. Okay, and we are going to see what are the different sections involved in our requirement specification document. So, for example, there are functional requirements in it, and there are different categories of non-functional requirements in it, and there are lots of other details in it. We are going to see that. And what are system stakeholders? So in general, a stakeholder is defined as somebody who is affected by the system. Okay, so it can be the developers of the system, it can be the client of the system, it is who is the sponsor of the project, who is the competitor of the project. So anybody who will be affected by that system, or who is affected by the system, is a stakeholder of the system. Okay, it involves supplier as well. So anybody who is part of the system is a stakeholder. So what is the relationship between requirements and design? Requirements and design, they are interleaved. Okay, they should ideally be separate processes, but in practice this is impossible. Okay, so one of the, if you recall those software development life cycle models, for example, the waterfall model. Now that is an ideal model. Okay, why I am saying this is an ideal model? Because in an ideal world, you would love to work on a product where requirements are finalized, and on the basis of those finalized requirements, you conduct the design, and then when your design is finalized, you go to implementation and testing, and now that is very smooth. Okay, but that's now how things happen in practice. So you are gathering requirements at the same time, you're working on the design at the same time, and at times you're also implementing stuff at the same time. So all these things are interleaved. Okay, so that's how things work actually in reality. So what is requirements management? So it involves all those processes and all those activities which deal with changes in the requirements. And believe you me that changes in the requirements is a definite. You know, this is going to happen when you are involved in software development. Then requirements are bound to change. Okay, so requirement management is very critical. So any processes or any activities involved with dealing with changes in the requirements, they are part of requirement management. Okay, now let's talk about what is systems engineering. Right? There is a very close relationship between software and more general system requirements. For example, when you talk about computer-based systems, they fall into two categories. Okay, they are user configured systems, where a purchaser puts together a system from existing software products. Then there are custom systems, okay, where a customer produces a set of requirements for hardware, software system, and a contractor develops and delivers a system. Okay, for example, when we talk about big ERP systems, for example, the products by SAP, Microsoft, Oracle, they are already built. And if a company or if an organization decides that they have to use an ERP, then they would pick a certain ERP system. It will not be developed from scratch. It will be customized and configured, and then it will be delivered to or it will be deployed or implemented at the client site. Whereas when we talk about the custom software, for example, I am a user and I want my website made. Okay, I run a grocery shop and I want my website. I want my web presence. Now that's a custom product, and I would hire somebody and I will say, okay, I want my website be made. Now that is something which is done according to my needs. Okay, whereas SAP is also implemented according to client need, but that software already exists. Okay, or any ERP system, it already exists. ERP is not the only kind of product which are configured, but that is a very relevant example, because when we are talking about those ERP systems, those huge systems, then we don't say we implement them, we say we customize them. Okay, because they are not they are usually configuration or customization switches which we change according to client's need, and we configure the system in a fashion which client wants. So in general, there are two types of computer-based systems. They are user configured system and they are custom systems. Okay, and so what are the classes of custom systems? There are information systems. Information systems are primarily concerned with processing information which is held in some database. Then there are embedded systems. Systems where software is used as a controller in some broader hardware system. And then there are command and control system, essentially a combination of information system and embedded system where special purpose computer provide information which is collected and stored and used to make decisions. So these are the main classes of custom systems: information systems, embedded systems, and command and control system, which is a mixture of information and embedded systems. Right, so another thing that we have to consider, or which we have to be very careful about when we are gathering requirements, or when we are in the process of requirement engineering, is that we need to think about the emergent properties. Now, what are the emergent properties? These are properties that emerge when different individual subsystems are merged together. So, and this is very common phenomena in software development, that different modules of the software, they are developed separately and then they are integrated together. Now, as a requirement analyst, we try to think about all the possible things, or all the possible things, or all the possible features in the product. And when we figure out what are the non-functional requirements, what are the reliability, security, safety requirements of the product, we try to figure out all the possible things that can go wrong with the system, and we try to cater them in our development. But at times, some properties emerge and which we haven't thought about, and they can affect any of those reliability, performance, maintainability, and usability of the product. So we need to be very careful when system or different subsystems of the product are merged together, and we have to look for those emergent properties. As a requirement analyst, that is very important. Okay, I think that's it, what we are going to cover in this introductory lecture. And so we have talked about different things, and before I finish the lecture, let me summarize what we have done in today's lecture and where we are going in the next lecture. So it was a introductory lecture. We begin with introducing the course. We talked about different course objectives. We talked about course learning outcomes, and as I said, this is the first course on requirement engineering that you are doing. So we are not aiming too big, but our goal should be to understand. And our goal should be to differentiate between different types of requirements and to come up with, let's say, a few list of requirements. If you're told that this is software, you should be able to figure out what would be the functional requirements, and you should be able to identify non-functional requirements for different types of systems. You should be able to appreciate that what is the importance of non-functional requirements for a safety critical system in comparison to an ordinary or a simpler software. Then I showed you the course outline, and we mentioned different books that we will be using in the course. And then we began formally our lecture today. And we begin with our definition of what is a system requirement. Okay. And and very briefly, what is a system requirement? It is any feature or any service that the system would provide, or it can be any constraint on the system. Okay. So in terms of service, we talked about library management system. For example, one of the service that it should provide it should maintain record of all the material in the library. For example, the books, the CDs, newspapers, magazines, and any other thing that is there in the library. And another feature or another service that this library management system should provide is the search facility, or it should be able to run reports, different kind of reports. For example, you want to see that how many books are overdue, so that is an example of a report. So these are different services. Then we can have different constraints on the system, that what sort of a system should it be, how should it be implemented, whether it should be a desktop application or it should be a web-based application. No, this is a constraint. Similarly, we can have more constraints, that how much time should every search transaction take when you are searching a book in the library or searching a CD in the library. So these are example of constraints. And then we followed our discussion on system requirements with different types of requirements, and we said that in the beginning we have very general or very broad requirements, and from those broad requirements we try to identify the functional requirements. Functional requirements are different features of the product which are concerned with certain functionality of the product. For example, the search for running a report or logging in users, and these are all examples of functional requirements. Then there are non-functional requirements, and within non-functional requirements there are multiple categories. For example, performance requirements or reliability requirements or security requirements or safety requirements. These are all different types of non-functional requirements. And then I thought something which is very important, and students often keep me asking, what is requirement engineering, or how do we define system requirements. So now we briefly talked about some of the questions that people ask me, that what is requirement and what is requirement engineering process and when to start designing a product. So we briefly talked about different FAQs, different frequently asked questions. And then towards the end of the lecture, we discussed that what kind of computer systems are out there. So mainly there are two types of system. One is that which we configure, and the other is the other custom systems. Okay. And in terms of configured system, we said that if something is already built and we are using that already built system, we are configuring it according to the client or the customer needs. And the other kind of systems are the custom-based system, which basically somebody is asked you to make from scratch. Okay, and then we discuss different types of those custom systems. For example, the information processing, then we have the embedded systems, and then we had the command and control system, which is a mixture of information and embedded systems. And then finally we talked about that there are some emergent properties which we need to be careful about as a requirement engineer or as a requirement analyst, because often software are built in different modules, and when we merge those modules together, then some properties evolve. Okay, and we might not be aware of them in the beginning, because these properties only emerge when different individual modules are merged together. Okay, so we need to carefully evaluate them, and we need to carefully look at them when we are dealing with our non-functional requirements. In particular, for example, reliability, safety, security, we need to be very careful with those emergent properties of the system. And we need to be aware of different modules, and we need to be aware of this. We need to look for these emergent properties when we are merging different modules together. So this is what we have covered in today's course, and in the next course we'll continue our discussion with introduction to requirement engineering process. and hopefully, as I said earlier, the goal in this course is not only to teach you theoretically what is requirement engineering, because there's lots of material out there on the web and in different books which teaches you, but we are also going to talk about the practical difficulties in gathering requirements, or what do people face in terms of our local industry, what are the problems when people go out there and try to gather requirements, and how to deal with those. And towards the later portion of this course, what we are going to do is that in each lecture I will try to come up with a sample set of requirements from real life software projects, and I will discuss those with you. So hopefully this course would not only help you in learning in general the requirements engineering process, but it should be you should be able to practically apply those principles as well. So thank you very much for today's lecture, and hopefully I will see you in the next lecture. Allah Hafiz.